Welcome to the Conjecture Institute podcast. The Conjecture Institute is a first of its kind where research across a diverse number of domains is being funded, though many of them have a strong scientific focus, and within that, many have a strong fundamentals of physics focus as well. And rather uniquely, it's all being informed by a Popperian approach to research and knowledge creation in general. It's as liberal and non-coercive a means of supporting knowledge creation as the founders can devise. So the Conjecture Institute is funding people who share the aims and interests of the Conjecture Institute. Lots of up-and-coming stars in quantum physics, mathematics, science, communication, AGI research, epistemology, aesthetics, even some economics as well. It's all about an optimistic approach to progress in people. And all of that, we might say, is building upon the Popperian framework which holds it all together. And today we have with us the person who has perhaps done more than any other to add a new and unique spin on Popperian epistemology, adding a kind of unique optimism to it all. Quantum physicist, father of quantum computing, author of The Beginning Infinity and the Fabric of Reality, winner of numerous prizes in physics, including most recently the Breakthrough Prize in Physics for contributions to quantum computation. And now we can add first advisor to the Conjecture Institute, David Deutsch. Welcome, David, to the Conjecture Institute podcast.
Hi, good to be here.
So, Conjecture Institute is seeking to solve particular problems, some of which I've just mentioned, but I'm not really going to ask you about the specifics of AGI or how to test for the quantization of gravity or build on Everettian quantum theory and so on. I mean, the problems that seem to have been created, I suppose unintentionally, by the existing ways of funding fundamental research, whether in the universities or via other funding bodies. So you're someone who has got experience yourself in seeking out funding for projects or assisting others who are seeking such funding. What are the problems with the ways in which trying to get government funding for scientific research or getting funding from any other institute like university research institutes are? What are the problems with those existing models?
Yes, it's not just government funding. It's really all funding, or nearly all funding, with the exception now of the Conjecture Institute. There is unfortunately, sort of single culture has developed over the funding of scientific research, and especially fundamental research, which has led to a single culture which is homogenized. And this has also been accompanied by a homogenization of career structures, so that everybody coming into scientific research field is expected to go through the standard career track, which is not appropriate for all different kinds of research. So one thing that happens is that a young person who is enthusiastic about a field, and really you have to be enthusiastic about particular things in fundamental research, because as my old boss, Dennis Sharma, said to me when we first met at my interview, when he decided that I was a good candidate, he said, "I have to warn you that there's no money in this field. It's only got worse since then." So what did he mean? Because everyone else would be thinking, no, there's plenty of money in the field. It's the expenditure on this kind of thing has been increasing over that time scale. And what he meant was that the kind of research that he did and the kind of research that I want to do does not have a proper career track. Not that one should want to go for a career, one should want to go for doing whatever is necessary for that research. And so one has to apply. And the first thing is one doesn't apply to the person with whom one is going to work. That is, in those days, I could apply to Dennis Sharma, and if he thought I was a good candidate, he could hire me with some of his grant. And he got a grant because he was a world-class researcher with a track record and so on. And in this case, the government funding agency the Science Research Council, as it was called in those days, keeps changing its name, which is another sign that bureaucracy is trumping actual meaning. He had somehow got that, and I didn't have to do anything except convince him. Now that's very different from today, because today I would have to not only convince him, I would have to convince the grant-giving authority as well. I would have to go for another interview and fill out another application, and that application would be full of, as I call them, checkboxes. And these checkboxes are necessarily all, I was going to say designed, but as you say, it's not a conspiracy. This is a state of affairs that has evolved under its own impetus. The checkboxes are all have the effect of militating against fundamental research. For example, at the very top, one has to fill in the name of the field. So I couldn't have filled in quantum computing because I didn't know that my research was going to lead to quantum computers. That's something I didn't know when I was a beginning graduate student. I knew that I was interested in the foundations of quantum theory. If I had to guess, and I did guess at the time, I would have guessed that this will lead to quantum gravity. Well, it never did, and it hasn't. And so I asked Dennis Sharma, what should I fill in there? And he said, just fill in anything. He guided me through the application process, which, as I said, was very, very mild compared with today's. There were no checkboxes then. So the checkboxes say things like, what is the expected impact on, checkbox 1, the field? Checkbox 2, the wider society. Checkbox 3, what's it called? Engagement with the public? I don't know what they call that nowadays. And so on. I couldn't have filled in any except by lying. In those days, all I had to do is write a short one-page essay on what I wanted to do, not what I wanted to discover at the end of the process.
I imagine if we plotted something like number of checkboxes on these applications or number of pages on these applications versus number of administrators employed by the university, there might be a very strong correlation between these two things. I'm not in the university system, but I do hear tell that many decades ago, the administrators worked for the academics and they were there to support and help the academics. But now it's kind of been flipped. If it's not one-to-one administrator to academic, the administrators actually outnumber the academics. And so you have what is often talked about now, this diversity, equity, and inclusion thing as well. Has that had any effect on, in your experience, especially younger people trying to move through the ranks of physics or engaging in physics research, that they also have to wade through these hurdles of diversity, equity, and inclusion things?
I've seen the occasional case where, for example, someone had to fill in a statement that in his research he's going to do so and so to advance diversity and so on. In other words, you have to swear an oath that you will let various other considerations trump the ones that you would have had to use in order to actually do the research. Although I can't say that for sure anyone's career has actually been ended by this kind of thing, because for the kind of research I want to do, as I said, people are not in it for the career. They're in it for the thing, and therefore they are, how can I put it? They are motivated to do whatever it takes to get the funding and pass the hurdles. So if necessary, they will make a declaration. If necessary, they will talk nonsense about the field and about society and so on, just so they can do the research, because otherwise they wouldn't get that. And in many cases, that would simply mean that they'd have to get another job and do the research on the side, because they are dedicated to it.
Yeah, and Conjecture Institute is trying to solve some of this by completely avoiding all of this checkbox stuff by supporting individual people. Everything Conjecture Institute is just getting started. They're just in the initial phases of really getting more funding and trying to figure out how to broaden the base of people that they support and projects that they support, I suppose. And we've already talked to a number of the fellows of Conjecture Institute, and I think you've spoken recently to the president, Logan Chipkin, about some of their plans. And one of their plans is a new branch for something they're calling Conjecture University. And to succeed, they're going to have to distinguish themselves in some way or other. And there's a statement from their funding document where they say, I'm just going to read from the funding document. It says, quote, "These projects address systematic failures in academia where groundbreaking ideas often go unfunded due to norms like incrementalism, empiricism, and explanationless science," end quote. So if they want a conjecture university, what do you think is the purpose of a university full stop in the first place?
Well, I have strong views about this, which I'm not sure how many other people share, though they should. I think that, and this is not a matter of going back in history, because in the whole history of universities, like for the past 1,000 years or whatever it's been, their academic purpose has been, over the centuries, polluted or sidetracked or even throttled by various other considerations like religion, and now it's the same thing is happening, but for a completely different reason. And again, I've got to stress that this isn't because anyone has decided that this should be so. Nobody has sat in a smoke-filled room with other aged academics and said, how can we stop fundamental research? That isn't how it works. But the way it works is that because the funding has to go through a bureaucratic process, this application that someone fills in with the checkboxes has to go to a committee. This committee then consists of what, 10 people, 20 people, who all end up with this large stack of applications. And they all have their expertise. They all have their opinions about what's important. They are all senior people. Therefore, they all have an idea about the future of their subject. And by definition, this doesn't include the next innovation that's going to change the subject. So, with the best will in the world, they are unable to identify the application that is going to change the field. And therefore, they choose things which they can be sure are going to change, are going to make progress. And therefore, that progress has to be incremental. So one of the problems is that the whole system is institutionally biased against fundamental innovation. And that's not by anyone's fault. It's simply because the method of choosing recipients goes through this bureaucratic process where the people judging it are asked to make a judgment on things that they can't possibly know. They are all of them, this document that you fill in with the checkboxes and the statements of, even if it's not DEI, it's the statements of impact and what the outcome of the research is going to be. People who are trying to optimize a particular thing, making a rocket nozzle that's more efficient than the previous rocket nozzle, they can say that we hope to make a more efficient rocket nozzle. But somebody who doesn't have a specific aim like that, but instead wants to, let's say, even as narrow as understand how chemical reactions are converted to thrust in a rocket engine, a person who is trying to understand something even as relatively shallow as that compared with fundamental physics won't be able to say so, because they won't be able to know what their discovery is going to be. They won't be able to say whether their result is going to be a new shape of nozzle or a new criterion for fuel or whatever. They just won't be able to say anything that the committee can put their finger on and say, yes, this is likely to work. So it's only the most incremental things that the committee can is competent to make a judgment on. And even then, let's say there are 20 people on the committee, they have 20 specializations in which they are experts. Outside that, they're going to be able to judge even less. So who is able to judge? The person you're going to work with is able to judge. He already has made that judgment. Of course, that kind of judgment is very error prone, just like funding startups in the economy. And in the case of startups, it's taken for granted that there are going to be many failures per success exactly for this reason. And that the funder need not be an expert in the thing that in the field, if there is one. And even if they are an expert in the field, they're certainly not an expert in how the field is going to develop.
Yeah. And so there's the question of what might be the impact of the research you're going to conduct, and what is the outcome of your research going to be, both of which seem to imply you can prophesy the creation of knowledge. You're going to be able to predict the outcome of the very thing that you're working on, which is the creation of knowledge, which is inherently unpredictable. We know that. But for people who don't, or people who want to play the game, it would seem to me, therefore, that it would be in their interest to be hyperbolic about what might actually be the outcome. And the more hyperbolic they are, the more disappointed everyone will be when they actually fail. But failure is baked into a lot of research. You're going to hit a dead end or go down a blind alley some of the time, but it's only by doing so that you're going to be able to figure out a thing that just might work. But I don't know if I'm filling out these forms, if you're actually able to say, I'm planning on failing multiple times before you actually get anything worthwhile out of what I'm doing, if ever.
That would be rejected, but not because the decision makers are hidebound old fuddy-duddies. It's because it's impossible to tell from that whether the research is worthwhile. Some people are good at detecting the right kind of enthusiasm, the right kind of angle to change things. And those people, and I've been lucky to have been employed by some of those people in the past. I don't know whether it would be possible now. Those people judge the person, not the outcome. And they expect to work with the person, which is another thing. Then they have skin in the game. They are making a decision that's going to affect their own research and their own life as they pick people. Now, this leads to another thing so ideally, therefore, a research group ought to have a very flat hierarchy. You said that the Conjecture Institute funds individuals. That's ideal, but I guess it's not going to be feasible for all kinds of research, because some kinds of research involve the collaboration of 5 people or 50 people. And then I think even then, it is extremely disadvantageous to have a hierarchy. So I don't know whether you can have one research leader who picks 50 people. Certainly you can't have one research leader who picks 500 people. So those research groups have got a fundamental problem that's over and above this problem of how the fund-giving entities ought to make their decisions. But so you said that the Conjecture Institute at the moment is funding individuals, so you don't have those problems. You can simply judge whether that individual has the right attitude towards their research.
I should make the caveat, I'm something of an ambassador or ex officio member. I don't know the nuts and bolts about how the Conjecture Institute actually goes about funding. Certainly there's possibly a mixture of broad topics they're interested in, and then at the moment, just individuals. But I imagine, yes, this idea of a flat hierarchy where no one person is directing what everyone else is doing is possibly a thing in the future for them. But as I say, that they're thinking of this idea of a conjecture university. And I think when people think of university, they think of what happens in an undergraduate style setting where people get into the university, they sit down in their lectures and in science. They go off to their labs and they do a set of coursework and exams, and they get the credential at the end of that. In your ideal world, let's say, how might this kind of thing be altered? It's been around for many centuries now that one gains the credential by going through these courses, sitting these exams, and only then getting to work with someone established in the field to actually create some new knowledge. I think there might be a few places around the world now where actually the keen 16, 17-year-old actually gets to work with the scientist. But at the moment, that is very much the exception to the rule. Can we avoid this way of training undergraduates, of even having an undergraduate system, having to go through 3-6 years worth of university coursework before we become a real scientist? How would you change things?
Quite radically, I'm afraid, which itself goes against some fundamental principles that I also advocate. But I think there's no choice. I think that the idea of a university as a continuation of school is inimical both to the educational purpose and to the research and scholarship purpose. So I would say, when you're thinking of founding a university, or the function of a university should evolve towards, don't start with undergraduates. I would say the fundamental purpose of a university should be research. It should be the creation of new knowledge. The university has an irreplaceable role, really, in that it is an institution that can dedicate itself to the creation of new knowledge independently of knowing what it's for, just for its own sake, just because it is something that humanity wants to know. But that then has a cascade of implications, because if you have an institution that's dedicated to research, that institution needs to have also a high level of scholarship. You need to have in that university, you need to have people who are the world's leading expert on medieval French poetry or the Cairo Geniza. As lately I've been finding the amazing amount of knowledge and scholarship that is in that field. Because research is impossible unless you have a background of that kind of scholarship in the institution. Now you have researchers and you have scholars. Of course, they needn't be different people. They could be, in some cases, the same people. But those two functions of a university require then necessarily a tradition, because those people are going to retire and they're going to be replaced by others. And where do those come from? They have to be trained by a university. Again, there is no choice. And that is what we would today call postdocs and graduate students. But that implies a career path which is quite bad. So shall we say they are people who intend to become leading researchers and scholars in that field because they are passionate about that field. And so that's 3 kinds of people, or 4 kinds of people that are going to be involved in this ideal university that I envisage. But then, if this thing is successful, and there are, even now, even with all these constraints and burdens that are on research in existing universities, there are universities with good reputations in all those fields. There are going to be people who want to partake of that atmosphere and of that kind of knowledge without wanting to join it eventually. There are people who want to, for example, learn about fundamental physics in order to hone their philosophy, their personal philosophy. Or there are people who, and vice versa, there are people who want to learn about philosophy because they will need it in some physics or some rocketry or whatever they are interested in. And those people can be funded for that reason alone. And that then takes us to undergraduates. Now, such people are paying guests of the university. It does not make sense to make them jump through hoops. Those people are guests who, because of their funding, can help to fund the other people whom they appreciate. They are there because they appreciate those other people, and therefore they can participate in the research and in the scholarship by having interaction with the top scholars and researchers. And that's what they're there for. You don't have to give them an exam. You just need them to be enthusiastic about that.
I can hear the objection from some who will say, but if I am the established scientist and I want to collaborate with somebody, I need to know that they have the required background knowledge in order to actually interact with me at the correct level. I don't want to have to teach them everything that is required. Let's say the mathematical, the techniques or the particular notation that we're using in this particular area of research. I don't have time for that. If they're going to come in at the level in order that they can contribute to the research, I need to know that they are competent at least with some of this stuff, and I don't have time to teach them. How do you cross that particular bridge to ensure that the person that you're working with is actually able to contribute? Is there some way of assessing their level of interest or engagement?
So nobody who enters a field of fundamental research is going to have learned everything they need to know as an undergraduate or as a graduate student. Fundamental research is deep. There are just too many different things to know. And everybody who comes into it is there to participate in the culture, really, to learn the culture, to learn the notation, to learn the problems or what people think are the problems, and to form their own view about that. And there's no way that an undergraduate course or a graduate course is going to teach them that. So that is a necessity anyway. But to know the basics, I don't think that's a real problem. I think the thing that if somebody comes into a field and doesn't know a particular basic, like I remember I happened to have not taken any courses in quantum statistical mechanics, nor in physical optics. So those are two things that I'd managed to avoid both as an undergraduate and as a graduate student because I found them very boring. And it turns out, as luck would have it, as bad luck would have it, that I needed both those in my own research. I didn't need to go to a course on that. Actually, Dennis Sharma said, "Why don't you go to a course?" And I said, "Yeah." And he said, being in the university is really quite a privilege because you can walk into any course. That's in Oxford. I don't know whether that's true in every university or whether it's true now in Oxford. I don't know. But he said you can walk into any course. So I said, I will if I feel the need, but actually I'd rather just learn what I need to do the research that I want to do now. And certainly, again, maybe this is too apt to be generic, but I certainly wouldn't have learned any complexity theory or computer science and so on in my learning of what would have been deemed necessary to do research in quantum field theory and curved spacetime, which is what I started doing. Now, that in itself was a field that didn't have any textbooks. It was that new at the time. How do you learn quantum field theory in curved spacetime? You read the papers, you don't understand the paper, you ask people around what they're doing, they give a seminar, you go to the seminar on what they're doing, you pick up the culture. It's really a culture. By the way, exams also just measure whether you're a member of a culture or not. They don't actually measure understanding because that's impossible.
Yes. I remember in a similar story back in 1997, I was an undergraduate studying astrophysics. And at that time, of course, everyone knew that either the big crunch was coming or the universe was just going to expand to a stop or something or other. But of course, that was the exact year when the dark energy problem and the accelerating expansion of the universe was discovered. Now, of course, there was no textbook you could have gone to become an expert on this thing. Best that anyone could do from a place like Australia was to just read the original papers that were there and maybe chat with some professors who understood some of the finer details. But that style of learning, of course, could work for anyone. And because it was new and exciting, all of the undergraduates were buzzing about it, because this was just it was at the cutting edge of science, but simultaneously that all these very young people were actually looking at this problem, understanding the problem, and I guess if they were allowed to, they could have contributed to the problem, but there were too many exams and other courses for them to take before they could actually tackle what may be the answer to this question. You've said that your original paper, the one that led to the founding of quantum computing, it wouldn't be accepted today if you had to go through that process now in 2025 or whatever. Why not? Why would it be more difficult to get that kind of thing published or funded today?
It's not the paper. So the paper was, in fact, held up for a long time, but not for this kind of reason. That was simply because it was a new idea, and you can't expect existing criteria to pass a new idea easily. But it was eventually accepted. The thing that I've said would not have been accepted was my original application to do this research. Once I had decided that I wanted to stop doing research in quantum field theory in curved space-time and switch to what is now called quantum theory of computation, I applied to do that, and I was accepted. And the story that I think you may have heard is that I recently met the person who was on the committee that gave me that grant. By the way, that grant, I went for an interview for that grant. So I applied, and they gave me an interview. And the interview was with 5 people. And what it consisted of was, they said, can you show us a bit of what you're planning to do? So there was a blackboard. It shows you how long ago it was. So there was a blackboard, and I wrote a few equations on the blackboard. And I said, I think this is not just a flash in the pan. This is a fundamental thing that will tell us something new about the nature of information, the nature of quantum theory, the nature of computation. And they gave me the grant. And so when I met this person recently, I said, I don't know if you remember me, but you were on the committee and so on. And he said, oh, yeah, I remember. I had to bully the other members of the committee to let you have the grant. There was one person there, not even the 5. There was one person who took it upon himself to bully the others to give me the thing. And then I said, if I were to apply today under today's criteria, would you have been able to give me the grant? And he said, no chance, because you wouldn't. This is why I keep talking about boxes. He said, you would have been able to fill out none of the boxes, literally none. Like that, there was a multiple choice. Nowadays, there's multiple choice boxes where you have different fields, atomic physics, laser physics, and so on. Long list. But that long list today includes quantum computation, quantum information. But then it did not.
Yeah. So this fellow did that job for a long time. Because there's some people who, okay, so they're research scientists some of the time, but they're also sitting on these committees for the rest of the time. And so they become like expert committee sitters and assessors of other people's work. Is that the way things are happening?
Yes. Again, I was lucky. I think there are very few such people. For a start, it's a different skill from the skill of actually doing the research. And it's a different skill from the skill of picking collaborators for you to do the research with. That is much more common, because basically everyone who wants to do something is going to be good at picking people to do it with them. But this skill of picking people in a different field, just because you recognize that they have, I don't know what to call it, that they have the enthusiasm. If you don't have the qualification, but you have the enthusiasm, then you will learn it quickly, just like I did with the quantum statistical mechanics.
So if we have, let's say, wealthy benefactors who may not be expert in physics or any other area of science, but they have a passion for science broadly and want to support the enterprise of knowledge creation, let's say, how do you persuade them? Or do you have any tips for how you might persuade someone to back what is inherently an unpredictable process of discovery, like your paper on quantum computing? What should wealthy benefactors like this, wealthy potential funders, expect? And what expectations should they let go of?
The thing they should let go of is the preconception that the existing criteria, the existing system is good at doing this. If you're a wealthy benefactor and you give financial support to something that is within the existing tradition of how to fund things and how to pick things to fund, then it's going to be wasted. Even setting aside DEI and all the things which are actually inimical, just the misconceptions built into the career structure and in the funding structure of everybody, almost everybody in that area, are going to make sure that your money is wasted. Instead, rely on, how can I put this? The top-down way of thinking about this is that the thing that is going to succeed is diversity. So the thing that wealthy funders, especially individuals, because large charities are subject to the same problem, they too are going to have to use this committee to choose where to give their money to. But a wealthy person or a wealthy family or whatever are going to be able to use the knowledge that they have and the interest that they have. For example, some wealthy people are interested in space research. Some wealthy people are interested in consciousness. Some are interested in the beginning of the universe. And they are, especially if they are self-made wealthy people, they are going to be used to picking people with whom they can work. And if they use that same skill to pick people who have a chance of fulfilling their aspiration to a Mars shot or a fundamental physics theory that tells us how the universe began or how consciousness works, they are best placed to pick such people. And then I would say, fund them unconditionally. Once you've decided to fund someone, fund them unconditionally, because otherwise the conditions that you make have a very large chance of putting a spanner in the works of the thing you actually want from them, which is novelty.
Are there examples from history that you're aware of that eschew this kind of grant application thing? Are there better ways that the scientists and other thinkers can secure some kind of support from the philanthropist?
Yes, I suppose historically this happened when people funded themselves. They were aristocrats or wealthy traders or whatever, and they had an interest and they funded it, and often they actually pursued it themselves. So someone interested in astronomy would make his own telescope and would put it in his garden and would make discoveries with it. And I think this applying to committees for funding is a relatively recent thing. I think it's really only taken off after World War II, when science itself burgeoned. So there are many more scientists because science turned out to be important for the military and turned out to be important for all sorts of large-scale government projects like energy and so on. I'm not against government projects, by the way. I don't know how I would fund a project requiring 100,000 people to work in collaboration. That's a different thing. But to think that the model of funding and setting criteria that is suitable for government starting a project for 100,000 people, that is suitable for funding fundamental research in general, I think is a mistake. Although now that I come to think of it, the Manhattan Project was a project for 100,000 people, which succeeded precisely because it didn't use nobody applied, as far as I know, to join the Manhattan Project. It was totally secret. You were picked, and then you were asked in a very veiled way if you wanted to work on a certain thing that meant you'd be away from home for years. And nobody went through a bureaucratic procedure. And then once they got there, they found flat hierarchies. I don't know who did that or why, or was it General Groves, or was it the urgency of wartime that made them bypass all the usual ways of doing things? Anyway, that is something that can work. It can also fail, but everything can fail. But if you want to make the fundamental progress, then the first thing to do is not to thwart it, not to strangle it at birth.
Just as a tangentially, does the fact of the Manhattan Project, 100,000 people or whatever, working in secret on a particular project and ultimately succeeding, does this at all challenge any of your thoughts about conspiracy theoretic thinking? After all, it was a conspiracy.
Yes, the thing about conspiracy theories that makes them never true is what I call a conspiracy theory is when people are doing something in secret and claiming that the thing they're doing is a different thing that's incompatible with the thing they're actually doing. So you're doing a thing to siphon off money from the public and you're pretending that you're trying to make a better light bulb, but actually you're trying to make a worse light bulb so that they'll buy more of them. That's the kind of conspiracy that is never true, because to recruit, one of the many reasons is that to recruit somebody to join that conspiracy is impossible. What are they going to tell their children that they're working on? Are they going to tell them the truth? Is there going to come a moment when they're 18, when their parents tell them, we're not working on what we said we were doing at all, we're working to fleece the public, and you can join and become a junior director in this, and then you'll share in it? They're not going to like that. They're not going to go along with it. And nobody will. Nobody is going to work towards something after they've been admitted into the secret, when previously they thought that the purpose of the thing was the opposite. So that kind of conspiracy isn't going to work. But the kind of conspiracy that the Manhattan Project was, they said to people, are you interested in coming to work on a project for the war effort? And it really was for the war effort. They couldn't tell them what it was until they agreed to join it and to become privy to all the secrets and everything. Even then, I suppose they were lucky, because they did admit a few people who were Soviet spies. Fortunately, they didn't admit anybody who was a Nazi spy. But then no project is immune from disaster. But they did the best they could, and the things that they did were largely the things that I would advocate any research project should do. They had it harder, but it's easier to form a group of 3 people or a group of 5 people using interviews and using word of mouth and friends of friends and colleagues of colleagues and new student that a colleague was very impressed by, but didn't actually think was suitable for their research. But they think, oh, this person is going to be very useful for this other guy's research. So that's the kind of thing which can work. And by the way, all those kind of things are illegal now. So you have to advertise the job. You have to advertise it with criteria that can be stated in the advertisement. It has to be a person who is skilled at so-and-so. Those are basically irrelevant considerations. So what people do, unfortunately, is often, when they can, they know who they want to take, and they set up the advertisement such that it's targeted to that person. And all the other 5 people who apply are never going to get the job, and they're just wasting their time, and it's tragic.
Like you, I'm not against, in some sort of principled way, things like the government funding of research, for just the reason you said. You've got the Manhattan Project, you've got the space race, the Apollo missions, and all the other associated missions to the moon and elsewhere that NASA accomplished. But it has often been said that only government could have achieved certain things. Do you think that in principle, in some distant future, that these large projects couldn't actually be taken on in a, let's say, less coercive way. The space race to Mars, for example, could be something that could be achieved outside of the government.
Yes, it's very impressive that the space race to Mars at the moment is currently being funded largely privately. That's very impressive. I don't think it could have been done in the 60s. The economy wasn't mature enough. It didn't have enough of the right kind of billionaire to fund such a thing. And I think that national defense is going to be one of the last things for it to be possible to be privatized, because a national defense company is going to be subject to political forces as well. It's going to have to meet political criteria, the same as a political party has to meet. And we don't know how to do that yet. We don't know how to devolve functions of the government, like national defense, onto the private sector. And some of the attempts to do this show what the problems are. Things like private prisons have political problems because their success as a private company depends in part on on political considerations that the usual incentives in a private company don't see. And with national defense, it would be much more. But I don't think there's any fundamental reason. And ultimately, everything is privately funded. Even the people who work for the Manhattan Project, they work for it because they decided to take that job at a certain salary under certain conditions. And they are a private contractor. Everybody working for the Manhattan Project was a private contractor hired by this government entity. So why not hire, instead of hiring one person, you could hire a small company consisting of 10 people. That it's not the same as having the project run like that, but I don't think there's any fundamental reason. It's just we don't know how to do it yet.
Yes. Speaking of private contractors, although I don't know if he'd like to be labelled that way, Sam Kuipers is one of the fellows of Conjecture Institute, and one of the goals of Conjecture Institute is to support Sam's work on a quantum mechanics textbook that you're working with him on, you're collaborating together. Why did you and Sam decide to write a textbook of all things?
Because young people who ask us questions or come to us and with a view to possibly doing research always say, what textbook should I read? Or what should I read? What papers should I read? Or what textbooks should I read? And there isn't one. There isn't even after all this time with so many people writing so many textbooks, there isn't a good textbook that avoids the quite basic errors of, for example, not using the Everett interpretation or including it as one chapter towards the end of the book where they get it wrong. There's just simple things like underestimating the Heisenberg picture. Typically, textbooks begin by studying quantum systems like the hydrogen atom and harmonic oscillator and so on, which involve a lot of mathematical superstructure that has nothing to do with quantum theory. You have to learn how to expand functions in terms of normal modes and so on, which you need and historically were needed to solve those early problems, but which now are pretty irrelevant to understanding quantum theory. Now there are textbooks already that try to start with quantum computation, but typically they have the wrong view of what information is. It could go on. This is just my take on things, which in the bigger scheme of things should be regarded as part of diversity. But there are no diverse quantum textbooks. They're all traditional quantum textbooks of one kind or another. So yes, there ought to be a dozen or several dozen textbooks with everybody else's idiosyncratic take.
And what's the process that yourself and Sam go through? Are you sitting side by side writing this textbook together? Or is there something else that makes the way that you're authoring or collaborating on a book a little bit different to perhaps the way other people author books.
Chiara Marletto is also an author of this proposed textbooks, and the way we work together is that we have a draft. This is, again, my idiosyncrasy. I have a horror of version control problems, where a collaborator is working on something, changes it, and then the change is either too much work to document it, and then you get to incompatible versions. So what we do is we have one of the three of us has the document at the moment, and then it passes to the next one and to the next one, and so round in a triangle. And very frequently, we also have a meeting on video link to discuss what our approach is going to be to the next topic. And that works very well from the point of view of getting the topic right and getting the version control right. It's a bit slow from the point of view of getting it done, but we want to get it done right so that when the next young person comes to us and says, what should we read? We can say, here, take this book.
I remember back in the 90s, after having just read The Fabric of Reality and going online to try and find more things by you, and this is long before the TED Talks or anything like that, there were the series of lectures on quantum computation that you'd done that were there, uploaded in the lowest resolution that possibly anyone was capable of finding. Is this like a continuation of that? Is it a similar sort of style?
Yes. So that series of lectures was a ultimately failed attempt to do this thing of telling the young person, watch this. Unfortunately, the funding ran out after 6 episodes. And anyway, I was finding it extremely burdensome to create a script and then work from that script. I found that was much harder than I thought it would be. Whereas writing a chapter, you can always go back, having written the next chapter, you can go back to the earlier chapter and change it to the way that properly introduces the next chapter and so on. Again, it takes longer, but it's more efficient in terms of content.
How will you feel if physics schools of the future take on your textbook and now have students sitting in rows doing examinations based upon the content in your book?
I can't express how horrifying that would be. We are, to some extent, doing our best to prevent that, but the textbook does not have exercises. There are no exercises at the end of the chapter. Instead, there are worked examples scattered throughout the chapters, where each worked example is then followed. Each example is then followed by the answer. So the example says, use this theory to work out such and such an answer. And then underneath that, stylistically in a different font and everything, is the actual answer. So it's not suitable for somebody to set a class busy work. They would have to edit. If they have a computer version, they would have to edit the document to remove those things. Or if it's a paper book, they would have to physically cut out those bits with scissors. And I suppose they'd cut out the thing on the other side as well. So it's not feasible to use this book for that kind of torture.
I wouldn't underestimate the creativity employed by teachers everywhere to figure out ways of doing busy work. You might need a single page right at the beginning with a philosophy of learning saying why it is that examinations and busy work are evil.
Yes, we might well do that.
Let's consider Carlos de la Guardia. He said that this article by David Deutsch was one of my major inspirations for working full-time on AGI, and that article was Creative Blocks. What makes Conjecture Institute, Carlos de la Guardia's AGI research, unique so far as you're aware of?
Oh, as far as I'm aware, he's the only person working full-time on AGI who understands the first thing about it. The first thing about it being Popperian epistemology and a few of my caveats about what not to do. So he understands all that. I don't know if there's anyone else in the world who is doing so. A lot of the people who think they're working on AGI are actually working on AI, and in some cases, wonderful, beautiful AI, but not at all on AGI.
Yeah, it's a subset of a person, and like for young people out there who are interested in contributing to AGI, it's a matter of reading some of your work, reading some of Karl Popper's work, actually understanding it, And there are very few people, it seems to me, in my experience, that actually do understand Popper, even if they've claimed they've read it, and let alone trying to apply that epistemology to this technological question, or insofar as a philosophical question about what AGI is, on which little progress has been made so far. That's the downside. But the upside is there's so much left to figure out. There's so many opportunities for people to possibly contribute. And even if people fail, let's say, in solving the problem of AGI, they may well make progress somewhere else in epistemology that could be very interesting.
Yes, that's a very frequent concomitant of failure if you're doing fundamental research in the right way. Failure is almost never pure failure. One normally discovers at least something about why one has failed and about what the landscape is that one has to navigate.
That also goes to the heart of the Conjecture Institute's philosophy about funding people, or ultimately funding a group, rather than funding specific projects. The specific project may fail very well. If you're funding the person, then what you're interested in is them pursuing their interests as far as they can go, and you may not end up, the growth of knowledge is inherently unpredictable. So what the Conjecture Institute is going to produce, even they can't say, even though they might be running the whole thing. Let's talk a little bit about constructor theory, because Conjecture Institute really wants to help with constructor theory. Do you have a pitch you would give to people interested in funding physics about constructor theory? Why is it different and worth pursuing as compared to all those other things that have been tried from time to time, so to speak?
Yes, I don't know if I have an elevator pitch, but I can say that there are problems at the foundations of physics which are concealed by the present received opinion about where the field is. For example, one of the big things is we have no theory of initial conditions. We have no theory about let's say the universe started at a certain instant at the Big Bang. What was the state of the universe, the quantum state or the average state or whatever of the universe at that time? We have no theory of it, even though the prevailing conception of what fundamental physics is says that all theories of fundamental physics should be of the form initial conditions, laws of motion. So we have laws of motion that are extremely successful. They have their own problems. The quantum field theory has its own problems and so on, but they are incomparably more advanced than our theories of the initial conditions. So we know that the universe is remarkably homogeneous on the largest scale. And at the time of the Big Bang, that largest scale was a very small scale, possibly zero, we don't know. That would violate the uncertainty principle. But anyway, but we know that it's not perfectly homogeneous. So because we see inhomogeneity, we see galaxies, clusters of galaxies and so on, all the way up to the largest scale that we see, we think that the homogeneity is only going to set in at the scales larger than we can see. Okay, that could be, but you'd need a good explanation to say that the fundamental principle only starts kicking in at the things we can't see. So is it possible that there could be a theory that in principle predicts the initial conditions and doesn't say that they're homogeneous? Well, the natural way of looking at this in constructor theory is that initial conditions aren't part of the fundamental physics any more than the final conditions are. And nobody thinks it's odd that we don't have a theory of the final conditions of the universe. We know that is going to be full of knowledge that we don't yet have, and therefore any theory of it would be teleological, and therefore, on the face of it, would have very bad explanations. So the same thing is true of the initial conditions. In fact, it's not really true that the existing mode of understanding physics says you have to have initial conditions and laws of motion. It says that you have to have laws of motion and some conditions imposed at some time or times. Roger Penrose had a theory once that imposed conditions on the initial and final singularity of some universe that collapsed. So there's scope for an infinity of different kinds of theory there. But in constructor theory, you just say that certain types of process are possible and some are impossible. For the possible and impossible ones, that means that you can or can't build a constructor that is a thing that can cause the thing in question to happen without being changed itself. And the fact that the assertion that a particular kind of constructor is possible tells you something about the initial conditions, logically. It's if you say that, for example, a universal computer must be possible, then that means that the initial conditions can't be homogeneous, because then no universal computer could arise. So a universal computer is a macroscopic object with certain specialized properties, and which are incompatible with homogeneity. So there already, I think that's a better take on the initial conditions than the prevailing take. So that's just one thing.
Just following up on what you were saying about motivations for constructor theory, and you're talking about the initial conditions of the universe, and obviously the dynamical law picture coupled with the initial conditions isn't going to enable you to predict what the initial conditions are, but constructor theory, a science of what is possible or impossible, let's say, may give you a window on describing that initial state, something like that.
It's not that the prevailing conception doesn't allow you to formulate a theory of the initial conditions. We could have. It's just that existing theories of the initial conditions are grossly inadequate, and there's no rival theory on the horizon. So one of the ways of dealing with this is to formulate a fundamental theory that doesn't make initial conditions fundamental.
And constructor theory, because it's silent on scale, it applies to the small things and large things as well, to emergent things in particular, which is an interest of mine. If you're looking at something what is traditionally not regarded as a part of physics, let's say like evolution by natural selection, or indeed Popperian growth of knowledge, these are things that we say are inherently unpredictable. It doesn't matter how much computational power you might want to apply to the problem. Using your next generation of dynamical laws, you're not going to predict the future using those dynamical laws. Okay, so put that to one side. If we have a more mature constructor theory of physics, could we have some sort of way in which physics could offer a way of viewing evolution by natural selection or Popperian epistemology by talking about the possible and the impossible in these domains?
I think that's very much on the cards, although when I say on the cards, I'm talking prophecy, and I shouldn't talk prophecy. But that is a direction that we think it is already going into. One of the basic problems of that type is the problem of the foundations of thermodynamics. What is the difference between these two kinds of energy that we have, heat and work? Existing theories of thermodynamics never get to the bottom of that issue, but constructor theory of thermodynamics does exist. Chiara has been working on that. And one of the early results, which I think is very impressive, but people don't seem to have noticed how important it is that in her formulation of thermodynamics, the first law of thermodynamics is information-based. One can define it in terms of constructor theoretic theory of information, just like the second law. That's a surprising result, and I think it reeks of significance, but we don't know yet where it's going to lead. But the constructor theory of information, which was our first success in applying constructor theory to a sort of existing field, already incorporated classical and quantum information into the same theory, which it isn't in the prevailing conception. The nature of information is now, according to constructor theory, integrated with the rest of physics. And that's very hopeful for thermodynamics as well.
So that's one of Chiara Marletta's many successes. One of her projects, I believe, is working on a gravity experiment. And I think, is that right? She's also working on that. And the Conjecture Institute wants to support that. I think it's an experiment that might cost something like $7 million over the next 5 years to actually do. Can you make the case for the importance of a quantum gravity experiment like this? What should people know about something like this?
So this addresses really, I would say, the most fundamental problem in existing physics, which is that our two best theories, which attain the highest level in Roger Penrose's classification, they are both what he calls superb theories. So they have known exceptions experimentally, and they have no known rivals theoretically. So that really elevates them to the level of superb. And yet they contradict each other. We know that there's something else, even though we don't know where in the theory that could be. We know that attempts to unify them into a single theory have all failed, and failed spectacularly. Some people have suggested maybe there is no quantum theory of gravity. Maybe gravity is classical. In other words, it's gravity as it exists in nature. Maybe it just fully obeys Einstein's general theory of relativity, and everything else obeys quantum theory. So then, how to put them together? There is this feature, which I think Feynman was the first to point out, but I know it from Bryce DeWitt, who called it the totalitarian property of quantum theory, which is that if you imagine two systems, one obeying quantum theory and one not, then if one of them obeys quantum theory and the other one you don't know what it obeys, then if they interact, the other system must also obey quantum theory. That's the totalitarian property. Or quantum theory doesn't apply to the first theory either, to the first system either. That's an argument that either quantum theory is wrong or gravity must be quantized. By the way, quantized does not mean discrete. Many quantum theories are discrete, and that's how it got its name, but that's not the fundamental feature of quantum theory as we understand it today. So when some people have argued, if there is no experiment or observation that can be performed that can detect the quantum features of quantum gravity, why do we need it? It turns out, as it always does in cases where something interesting is said to be unknowable, that actually there is conceivably an experiment where one could detect that gravity obeys quantum mechanics. And that is the experiment that Chiara and others are proposing. It was proposed simultaneously by Chiara and by the group of Chiara and Vlatko Vedral, and also by another group led by Sugato Bose in London. So again, when the same idea comes up independently in two different groups working on the same problem, it's not a sign that it's true, but it's a sign that it has to be pursued.
Yes, and given we have Large Hadron Collider finding the Higgs boson for many hundreds of millions of dollars, this is pennies in order to figure out whether or not gravity has these properties.
Yes, and whether it succeeds or fails, this experiment is virtually guaranteed to tell us something new. Because if it tells us that gravity is classical, then by the totalitarian property, that tells us that there must be errors in quantum theory, even applied to non-gravity things. So that would be a revolution. And if it tells us that gravity is quantum, then that will open the door to working out how, in what way is it quantum, in what way is it compatible with existing quantum theory. And that might open the door to an actual quantum theory of gravity. I think it's a paradigm example, if I may use the forbidden word, of something that needs to be done. The Conjecture Institute is quite right to think so too.
Paradigm straddling example, perhaps. Yeah, you've posted very kind words on X about Conjecture Institute fellow Arjun Kamani's documentary. He and Logan wrote a script together for this documentary. I know that Conjecture Institute plans to support and create more documentaries and explainer type videos. This is going to be part of Conjecture Studios. What stood out to you about Arjun's documentary as impressive?
It's simply that it conveys the importance of fundamental ideas, and especially fundamental ideas in physics and in philosophy. And it expresses them in a way that one doesn't need any previous knowledge to understand. One does need a certain amount of previous enthusiasm for this kind of issue. If you're not interested in how the universe works and are only interested in classifying different ways of making ships out of matches, then this may not be for you. I'm not disparaging that. I was trying to think of something which is obviously worthwhile, but nothing to do with physics or philosophy. I thought they were brilliant videos, and I told you earlier of my discovery that making videos is extremely difficult. And so I appreciate they have done it well.
And of course, to my mind, as you explain in the beginning of Infinity there, the trend in science documentaries or documentaries of this style most recently is to be saturated with the pessimistic culture that just permeates everything at the moment. Humans are damaging, we should minimize our impact. Why would we want to go to Mars or the moon for fear of polluting those places when we've done enough damage here? So anything that can counter that in an easily digestible way is an important project for humanity, I think, at the moment. From what other things you've seen as far as Conjecture Institute is concerned, is there anything about what they're doing that intrigues you at the moment?
I'm interested in whether this model can be extended. At the moment, I don't know exactly how, like you, I don't know exactly how the Conjecture Institute works internally, but they have managed to direct funds towards people that I know are worth supporting. Somehow they know. And there's also this element of optimism and the philosophy of the whole thing, which is starkly different from the philosophy of the culture generally at the moment. I didn't mention, when you said, what do I think of Arjun's video, I didn't even bother to mention that it is optimistic. And that alone sets it aside from almost everything that's being offered to the public at the moment. And I think the Conjecture Institute is also an instance of optimism being translated into something concrete, something that can be taken further. And I'm interested in whether it can, for example, go on to fund a number of people that can't all be known about by a small number of decision makers, whether it can go on to fund projects that require large numbers of people, or at least larger numbers of people, 10 people, 20 people, whether it can fund that. And, of course, whether it can attract funding from, and I think correct me if I'm wrong, but I think the target potential donor set is wealthy individuals. I think wealthy individuals with a worldview that they would like to know more about, where they have their worldview, they have their area in which they are expert themselves, and they wish that something else was more known so that they can know about it. So if they saw a book on Amazon that was exactly right, they'd buy it. And if there is no such book, they would like to buy the research project that might eventually lead to that book, or to a better book.
Speaking of books, like one of the Conjecture Institute fellows is Ray Scott Percival, who wrote that book, The Myth of the Closed Mind. It's that style of thing. So we've got optimism about humanity and civilization as a whole, but also on the individual basis of trying to understand a little bit more about what thinking processes are going on inside of people's mind that don't actually ultimately close them off to learning particular things or changing their mind, which seems to me to be the prevailing view about this understanding of biases or being cognitively closed to certain things. And you're writing your next book is something similar. Have you got anything to say about this without giving the game away, but how things are going there and what the general theme is?
Yes, you're right that my next book, whose provisional title is Irrationality, although this may be a bad title, and maybe it should be called Rationality, but then that sounds as though
That's
I'm
pinker.
trying to lay down the law about what is rational and what isn't, which is the last thing I want to do. Yes, it seems that the world has, or shall we say the West, has gone down a blind alley in which it has taken up on a large scale ideas that are inimical to the growth of knowledge and which even are destroying existing knowledge as we speak. There are very few projects, intellectual projects, that contradict this. I remember thinking when I first saw Bronowski's television series and then the book which came from it, I envisaged Bronowski as a sort of single-handedly trying to stop the flood coming from the broken dam of Western thought and divert it into a productive path. And I think I don't know to what extent he succeeded with his readers, but I don't think he succeeded in halting the deterioration in society at large at all. And I'm trying to do the same thing. I'm trying to say, yes, there is such a thing as truth. Yes, there is such a thing as knowledge, but it's counterintuitive what its properties are, and people have got it very wrong. And even apparently benign mistakes like empiricism are now rising like zombies, and see it all over the internet where people are saying, people have seized on the trope of what evidence is there for that, which one has to say there is no such thing as evidence for something, and you need to adopt a critical attitude. And they don't hear what you're saying. And if you do provide evidence which contradicts the line they're secretly promoting, then they will say, what evidence do you have for that?
Or point me to the peer-reviewed paper, or having done so, there's only an N of 1. That's not persuasive.
Yes. And what evidence is there for Popper being right? By the way, they never say what evidence is there for Bayesianism being true.
They're highly confident that it's correct. That's all that's required.
Yes. So what is there prior for Bayesianism being true? And if it's not one, which, by the way, thoughtful Bayesians maintain that credence can never be 1 or 0, because that means it could never change and so on. If it isn't 1 or 0, if you think it's 99% or whatever, what are the implications for that remaining 1%? What precautionary principle should we adopt for the contingency that Bayesianism is false? But Bayesianism is one of the more benign errors that are besetting Western culture at the moment. There's also that whole spectrum called woke, which is the successor of postmodernism, and postmodernism kept changing its name. I don't know whether woke is a new name of postmodernism, whether there'll be a new name soon, I don't know. But it's full of contradictions, and it doesn't mind because it doesn't think that contradictions are bad, because it doesn't think there's such a thing as truth. And if as soon as you accept that there isn't such a thing as truth, then you can discard all criticism of any position that you have by saying that that's just a narrative. So then you have a narrative, but it's even worse, because not only does it allow you to denigrate all criticism of your position on principle, it declares that there is no difference between honest pursuit of an idea and dishonest pursuit of an idea. So, of course, we're all going to be lying in pursuit of the paradigm or the narrative that we all are slaves to.
Well, that very technique, this technique of argument and criticism, is just a consequence of the colonial project, which is evil anyway. So merely trying to defend it is a demonstration of your being enthralled by these terrible ideas.
Yes, and so they would say, and this thrall causes you to repeat lies or to just lie. which is in fact only true of them.
Yeah, so holding back this deluge or this flood of information and lies and just bad philosophy in general, it seems to me, in one sense, is being done in practice by someone like Elon Musk, who's building rockets and actually making concrete progress without actually necessarily being able to articulate himself how it is he's doing what he's doing. After all, as you point out quite often, anyone who excels in a particular area does so because they are implementing the principles of Popperian epistemology. That's how you make progress. And then so it seems to me they are a beacon of the Enlightenment, a demonstration of the Enlightenment. Then you do have other people who are very rational in the intellectual world who are trying to defend a kind of rationality, but it's not usually the correct one. And so it seems like the Conjecture Institute and the people that are within it serve this very important purpose that they can all articulate the way in which progress is made, has been made, what needs to be defended. And hopefully this is a part of your book about the mechanism, like the engine of knowledge creation, I suppose, that enables humanity to continue to thrive, the very things that allow us to escape that, the lack of progress that you talk about throughout the beginning of Infinity, what kinds of things we need to protect in order that continues.
Yes, and as you said, there is, in addition to this deluge, there are also very many people who are desperately trying to find a way out of this to prevent themselves from drowning. And any kind of claim to rationality, like Bayesianism, for example, is eagerly grasped by people. And that, if to the extent that is a shield against open irrationality, that is a good thing. Now, it's not actually true. So Bayesianism isn't actually true. Or rather, Bayesian epistemology, I should be careful to say, isn't actually true. The empiricism isn't true. Both of them can be a lifeline or a path out of the prevailing anti-rational, can I say consensus? I think I can also almost say anti-rational consensus that exists now.
I guess I often framed it as in the same way that, empiricism, enlightenment, continental rationality, rationalism, so to speak, were an escape at least from the prior doctrines of just pure authoritarianism, so that they have virtue in that sense of saying you don't just need to take on faith what the priest says or what's in the holy book or what the politician says. So they're escape from that. But it seems like now there are many people who've turned back, who've forgotten about even the empiricism and even rationality, have just returned to rank authoritarianism. The academic says it, or the dogma that exists in politics says it, and so therefore it's true because of consensus. This tribal group says this thing is correct, and we will teach our children that and we'll promulgate it through the university. So
sometimes what the academic tribe says is that there are tribal ways of knowing in the old sense of the word tribe. So they say, we are not actually the way to truth, or at least we're not the only way to truth. We need to elevate other ways, millions of different ways of conceiving of truth.
Now, we have it in spades here in Australia. Yeah, so I don't suppose you're quite plagued with it in Britain to the same extent that we are. We will literally turn to tribal ways of knowing, which upon investigation rarely are true, are often made up on the spot, apparently. They claim a long lineage of this traditional way of knowing. In Indigenous Australian culture, there literally is no written record. It was all oral tradition. So you can make it up tomorrow and claim that it's a new way of knowing.
Yes. So there are people who viscerally rebel against this, and they are looking for a rationale for them to join. And as I said, there are several that are actually not true in themselves, but can be salutary for many people. And the Conjecture Institute are going to be a beacon of the right epistemology, which is the right way, which doesn't have internal contradictions or well-known flaws yet. Maybe in the fullness of time it will, and then there'll be something even better. But yes, it is a good thing in that sense as well, that in society needs this.
Yes, and can accept that there's no final answer, there's no settled science, and that in order to be able to make progress, we need to have the free exchange of ideas, and free speech is important. I noticed, just as an aside, someone we mutually admire, Daniel Hannan, he tweeted out that he thinks Britain and Europe broadly need a First Amendment. I'm really curious what you think about that. Does Britain and Europe need a First Amendment?
No, I'm against written constitutions. I'm against laws which require an unusual amount of criticism or refutation to change. I think Britain already has the ideal system, or at least the best known system in that respect. It's very dangerous because what having a First Amendment would mean is that one day some government and the people will agree on some measure and some court will say it's unconstitutional. It violates this First Amendment, even though everybody agrees it's a good thing. And then at that point, argument is disabled, persuasion is disabled, and it's replaced by the opinion of some judge. That has already caused a tremendous amount of damage, both in Britain and in the US. What we want to do is to move away from that. Free speech, the protections of free speech in the US Constitution and in the EU laws and so on, they began in England without a constitution. They were all ways of trying to foist the traditions that had already grown up about free speech and so on unwilling politicians. But as soon as you do that, you're foisting it on the unwilling population as well. And that leads to faction, it leads to irrationality, and ultimately it leads to violence. Like in my opinion, the US Civil War was caused by exactly this property of the US Constitution. The Supreme Court was just made of people. They had prejudices of their tradition and their class, and they enacted into law something that was unacceptable, that was incompatible with the general evolution of moral reasoning among the population. And the people who found it incompatible had no choice but to resort to violence, like John Brown and so on. And the people who were not yet persuaded had to invent a stupid theory that they could align themselves around, namely what we would today call race realism or race essentialism or something, that said that visible attributes of a person, like their skin color, is actually related to some deep thing inside them, their genes or whatever, which is immutable and therefore justifies doing all sorts of what would otherwise be immoral things to them. And to give him his due, Abraham Lincoln used the correct argument. He said he had no idea whether intelligence is inherited or whether Negroes have the inherent ability to make sophisticated judgments or whatever. He said Negroes may or may not be inferior, but if they are, that does not mean that they are not entitled to the fruits of their own labor. So he had the argument that this defense used by the South doesn't make sense. It doesn't address the issue. Either way, slavery is immoral. It's an abomination, and so needs to be abolished. And that was the reason his party was formed. And yet they fell into the trap of saying, instead of making that argument, basically saying your culture violates the principles of the Enlightenment, as I would put it today, they said, you're racists, and therefore you are to be opposed, which doesn't even address whether they are right or wrong. And that argument, you are a racist and therefore wrong, may or may not have worked to win the argument in the Civil War, but it has had nothing but bad effects ever since.
Yes, the stifling effect at the moment that people talk about on free speech, I can't remember if it was one of the Johns, I don't know if it was Locke or Mill, but talked about, never mind what the government does in terms of legislation against free speech or whatever, the broader culture can have a serious effect on what people feel willing to articulate in the public square. And so that is the kind of free speech that one should want to ensure flourishes in some way, but culturally. However, I guess what that doesn't solve, and I think what Hannon is concerned about, is what's going on in Britain with the bobbies turning up on people's doorsteps complaining about Facebook posts that have been made. So that kind of thing apparently can't happen in the United States because of the First Amendment. So what do you say about that?
This is, in Britain, this is an issue which makes a lot of people think that the government has gone down the wrong direction. If they continue to think this, there will be pressure on the government or on the next government to change this in a way that makes more sense to more people. Absolute freedom of speech is just a phrase. It doesn't really tell you where to draw the line between, for example, political speech and incitement to violence. There was a problem in the early 20th century in America with gangs, where the gangs were structured in such a way that the boss of the gang could intimidate the gang and everyone else and could bribe officials and lawmakers and police and so on without ever committing a crime, without ever murdering anybody and so on. So they had to introduce legislation which arguably impaired free speech, which made it a crime for somebody to be convicted, which made it a crime for somebody to say, things would be a lot better if Fred Smith were not here anymore. And his lackeys, the other people in the room, know that they can tell their gang bosses, and the gang bosses can tell their thugs, so that there's a long chain of untraceable causality between what the gang boss says and somebody, if the murder somebody commits, and you can't convict the gang boss. So you have to make it a crime to engage in certain types of conspiracy to perform crimes and certain types of incitement to commit crimes. And as I've been saying lately, we at the moment are suffering, we in the West, but in particular in Britain and America, we're suffering from certain things which are just harmless opinion, or rather non-criminal opinion. Harmless is a different issue. Communism is harmful, but it should be legal to advocate it. But it shouldn't be legal to advocate some mass murder. And there are people who are advocating mass murder at the moment and are untouchable under laws of free speech, which this law that this First Amendment that Hannon wants might entrench, not solve. We're going where our society is being dangerously undermined in both directions. Both speech that is not criminal is being criminalized, and speech that should be criminal is being protected.
Yes. The answer, I suppose, is people learn more about the way in which knowledge grows and understand the distinction there. Obviously, there is a reasonably clear line to draw between this kind of speech is going to lead to death, destruction, and the destruction of error correction in particular.
Yes, if that could be made the criterion, then everything would work. But I think that isn't understood well enough by the people.
Or maybe in a few years, once the Constructor Institute has achieved the status of the Royal Society or beyond, right, then maybe we'll be able to implement some of these things in the legal system. But thank you so much for your time from the Constructor Institute, insofar as I'm the ex officio member of it. Are there any final words you'd like to say about this particular project, or your hopes for the future about what might come next before we let you go?
I can see that it's already doing good in this small-scale version, both in people it funds and in presumably raising money for it. I hope and expect, actually, that it can scale up in both respects.
Absolutely. Hopefully that is the future of the beginning of infinite progress and optimism. Until next time, David, thank you very much. Bye-bye.
Bye-bye then.